So today we have to start solving exponential functions. So the first part we have discussed last time. So we can think of three different variations. The first one is when you have this kind of a shape where 2 to the power x is equal to 8. So this is so easy. The reason is 8 can be written in terms of base 2, right? So 8 can be written in terms of base 2. So this is a very easy question. Now there is another question type where this 7 cannot be right in terms of base 2. So if it is, if you see this kind of a problem, so there is a strategy that you can do. The third variation would be quadratic form. So you can see 2x here and x here. So this is a quadratic form, right? So we are going to discuss that in detail today. So if you have a quadratic function like this involving exponentials, you have to recognize the quadratic nature. So 2 to the power x 2, so this is the quadratic nature. And with a suitable substitution, you can have a proper quadratic equation and then solve for it. So today we are going to discuss about all these three variations. Now, variation number 1, I would say A, right? Variation number 1, it looks like this. 3 to the power x is equal to 27. So solve for x. Solve for x. So now this is very easy. You can write 27 in terms of 3 to the power 3 and 3 to the power x. You can see these bases are the same. So x should be equal to 3 in this case. So to hold the equality, x should be equal to 3. So that is pretty easy. With 1, so that means the second category. So this is what we have to really understand. So you have 2 to the power x is equal to 7, right? So the question is solve for x. So here we have a problem. The problem is we can't write this in terms of 2 to the power something. So there is a new technology we are going to introduce here, and that is logarithms, right? So the new technique to solve these kind of equations is called logarithms. So we have to know this as a fact. So how this works? So 2 to the power x is equal to 7. What we do is we are going to introduce a log function to left hand side. The same thing should be done to the right hand side. Why? Because this equality should hold true. So what we are going to do, I'm going to introduce log 2 base to the left hand side, and the same thing should be done to the right hand side. So if that happens, you can write log 2 to the power x is equal to log 2 7. Now you have to understand why we introduce log here. What is the purpose of introducing log here? That I already explained to you in the with part. So there is a log property which I will be teaching you those log properties in the log lesson. But to do this question, we will use one of the log property. If you have an exponent like this x here, you can take that out. That is one of the log properties. So I'm going to give that as a small note here, so that you will just know this. But I will discuss this in detail in the log session. So this is nothing but log p qx can be written as x log p q. So you have to know this one. Then there is another one, log 2 2. Log 2 2 is 1. So that this tells you that log pp also 1. Log 10 10 also 1, right? So you can write it like this. There is a defined pattern, so you can observe that. So just know these two for now, for our simplification. Details I will teach you in log class. So I hope you understood the logic behind why we are using log. Right. So now in this question, what we have to do, so we defined log 2x is equal to log 2 7. Right, put the brace. Then this x can be taken out, so it's going to be x log 2 is equal to log 2 7. Now we understood that from the previous note, this is going to be 1, and that is what I discussed here. So that is 1. So from here you can find x to be log 2 7. Right. Now we go a little deep and discuss this. If you really look into this, 2 to the power x is equal to 7. You have to understand why we introduced log 2 base. Why log 2 base? Why not log 10 base? Why not log 10 base? The reason is very clear. If you introduce log 2 only, you get this compatibility. If you have that compatibility only, when you take x out, you can see this 2 pattern. Then only you can say this is 1. So that's why we introduce log 2. Otherwise, someone can think, why not log 10? I hope this is very clear. So now we'll discuss what if someone introduce a different base. For example, 2 to the power x is equal to 7. So we are going to introduce not log 2 but log 3. We'll see what will happen. So if you do that, you are going to get log 3 2x is equal to log 3 7. So this step is still valid. Now we are going to bring x out. So x log 3 2 is equal to log 3 7. This step also valid. However, you can't claim this to be 1. This is not equal to 1. Right? So that is not equal to 1. So how do you find x then? X is equal to log 3 7 divided by log 3 2. So what we did was we cross multiplied. So this is correct too. So now if you compare this answer versus the previous answer, what was the previous answer? Previous answer was log 2 base 7, because there was a 1 here, right? The reason behind this one was log 2 2. Okay, so what we got was x is equal to log 2 7, right? So this is correct too. So this will tell you that these two are equal to each other. These two are equal to each other, right? Now when I was a kid, my teacher taught me, when I was in year 11 class, my teacher taught me a concept called change of bases, right? So for most of the students, this was a new technique, right? When I was in year 11. However, this was not a new technique for me, because I have gone through this already. I didn't go through the year 11 content, but exactly I learned in this way. So I simplified in my own time. I simplified the same question in 2 different ways. This is the methodology my teacher taught me, like I'm teaching you right now. But then I thought, why I'm introducing always log 2? He took always log 2. But I was asking this question, why always log 2? We can introduce anyways into both sides. So I did that. So when I got that, the same x. Okay, I'm going to write that here actually, right? So what I'm going to write, I'm going to write this set with this, right, in a new in this in here in the new page. So x is equal to what I have was log 2 7. Log 2 7 is equal to, so here if you look at it, log 3 7 log 3 2, log 3 7 divided by log 3 2, right? So this is the summary. This summary I knew when I was in grade 9. Nobody taught me, but it's just a simple observation. That's where that we have to have our own time in learning. Now I was just looking at it, right? So I saw a nice pattern. That pattern was this 7 always appearing here. The base 2 always appearing in the denominator inside the log function. Then I was thinking, what is this? 3. Same thing. Same thing. Then I was doing this experiment, right? I was doing this experiment further in further details, right? So what I got, so what I did is this, and then I will show you like what I have obtained. Okay, I'll give you another note. So the question was 2 to the power x is equal to 7, right? Earlier, I was introducing log 3, right? Then we got this relation. So now what I'm going to do, 2 to the power x is equal to 7. Now I'm going to introduce log maybe 10. I'm going to introduce log 10. Mathematically, this is valid, logical. We are introducing the same thing in both sides in the equation. So I'm not going to discuss this because this is what we have done before. I'm going to discuss this. So the answer to this one, if you do the right math, I'm going to write the answer. It's going to be log 10 7 divided by log 10 2. This is what I get. Now, end of the day, it's the same x. End of the day, it's the same x. I did this experiment. Nobody taught me this. So then what I did, the same x we are talking about. So I copied this one here. Then I wrote this one to be log 10 7 divided by log 10 2. Good. Then again I saw that even after I'm considering a different base 10, this 7 is copied in the numerator, base 2 is copied in the denominator. Then my observation was, if your base is 10, the introduced base is 10, and that is copied top bottom. Then I conclude myself this important thing. The base in this scenario, this base 10 or 3, right, is a dummy base. Dummy base. Dummy base means you can have anything. You can have anything. This concept indeed is called change of base. So change of base concept I showed you in a more logical manner. If someone want to learn right math. Okay, some people try to memorize, but there will be consequences. So we obtained change of bases, the concept of change of bases. Okay. So if you generalize this, x is equal to log 2 7 can be written as log p 7 top to top. This is what I understood, top to top. So that word came naturally to me right now. When I was in grade 7, I understood top to top. Then log p to bottom to bottom. That's how I understood, so that anytime I can use it quickly. Okay, top to top, bottom to bottom. The new base, which is p, can be any number. This can be any number. So initial base was 2. changed base was p. So how you do that? The relation is in front of you. Okay, let's discuss this question, right? Convert log 2x in terms of base 10. So that means this original base 2 should be converted into 10, right? So this is very similar to currency exchange, right? Australian dollars to US dollars, currency exchange. So you are changing the bases. So now we will stick with our basics. So log 2x can be written as, so top to top, look what I'm doing, log x, top to top, bottom to bottom, log 2. I peacefully put that there. Now I told you my base can be anything, right? My base can be anything, right? This. So I can put any base, but it should be the same once I use it. So I need to change that into 10, right? So I'm going to put 10 here. Is it valid? Of course, that's what we were discussing about. It is valid. Now what you do, you cross multiply. What do you mean by cross multiply? You put this guy here. If you do that, you get log 10x is equal to log 10 2 times log 10 2 times log 2x. So now if you carefully look into this part, if you carefully look into this part is a number. This part is a number. So we don't have to worry about it. So log 10 2, and this is the unknown part, an unknown part. Right? So this will give you a relation between log 10 versus log 2. That's a relation. Right? So you can play with it. This is just an example to show you how this works. Okay. Now, third and the last category in exponentials. Quadratic nature of exponentials. Quadratic nature of exponentials. Okay, so if you have something like this, okay, so let me come up with this. 2x minus 3 times 2x, okay, plus 2 is equal to 0. Plus 2 is equal to 0. Solve for x. Right? So this is one of the structure you get in the exam. So you will see the quadratic nature. You have to observe. Look at the quadratic nature. See, there is a difference between this term and this term. So this guy, if you use the index laws, right, grade 5 math, this is nothing but 2x to the power 2. So this is like power of a power. So this is a power, this x is a power, and this is the next power of a power. You can think it that way. And then 2 to the power x is 2 to the power x. Right? It's like this, power 1. So now you can see the quadratic nature. How do you know the quadratic nature? You can see here, see, 2. You can see the quadratic nature. So what you can say, let k is equal to 2x. We do this substitution. We must do this. right? So you better understand it and use. So if k is equal to 2x, right? So from the first term you get k squared minus 3k plus 2 is equal to 0. So this should be pretty clear, right? Now I'm going to solve this. So this is going to be k minus 2, k minus 1 is equal to 0. Now we can use null factor law, NFL. If you use null factor law, k is going to be 2 and 1. Now this is our third technique. That's why I put C here. Now what we can do, after finding k values 2 and 1, I'm going to substitute that back into this, right? So what will happen, 2 to the power x is equal to 2, then 2 to the power x is equal to 1. Now what is the technique we use here? Let's see, observe, 2 to the power x is equal to 2 to the power 1. Here 2 to the power x is equal to 2 to the power 0. So we can write this number in terms of base 2. We can write this number in terms of base 2. So the methodology A is used in both cases. Okay. So from here, very easily, you can find x to be 1. And here you can get x to be 0. Right, so that's the answer. So we will discuss a similar question. Okay. Solve 2 to the power 2x. Then minus 5 times 2 to the power x, right? Plus 6 is equal to 0. Solve for x. Okay. So here again, I'm going to say let k is equal to 2x. I can see the quadratic nature. Then after substituting that, you get k squared minus 5k plus 6 is equal to 0. Now you are going to factorize it. So it's going to be k minus 3, k minus 2 is equal to 0. Now use NFL. If you use NFL, you get k is equal to 3 and k is equal to 2. So once you have k values, then you substitute that back into what? This. And then find x. So I'm going to write it separately now. 2 to the power x is equal to 3. Then 2 to the power x is equal to 2. So I have to simplify these things separately. So this one I can write 2 to the power x is equal to 2 to the power 1. So from here you get x is equal to 1. So what methodology we used here? Methodology number A. Why? Because 2 can be written in terms of base 2. So methodology number A. We have to precisely know this. Right? Now, if you go here, now we attempt to write 3 in terms of 2, we cannot, right? So 2x is equal to 3, so we can't write 3 in terms of 2. So the strategy would be introduce log 2. You can use any base. However, if you choose log 2, so that this 2 and 2 compatibility exists, so that way it's easy to get the answer, right? So then you are going to bring this x out. So it's going to be x log 2 is equal to log 2 3. So finally you get the answer x to be log 2 3, right? So what would be the strategy we used here? We use strategy number B, right? Here we use A, here we use B. Now if you look at this section over here, what is the strategy number we used here? C. So in this question, all 3 strategies are used, A, B, C, which I taught you step by step before.